was the second set of slides. That was the unfinished one. So there was some information that it was not clearly written when I was drafting the slides out. For that reason, I have uploaded a new one. So please, Ming, you can hear me well? Hello, Ming.
Yes, Doctor. Yeah, I can hear you well.
Okay, good. So that's so I'm gonna share the new slide just for the sake of being quick, in case that you are using that. So let's say we continue a little bit with section 2, where we still have something to do, and then we move on to the optimization. And in the afternoon, as I suggested, we are going to do the data processing. So I hope that by this morning, you all will develop a kind of familiarity with the idea of programming in Python. So let's say last time we finished with share the screen, right? Share the screen, and I will report the lecture.
Recording in progress.
Good. So we finished with the LRLM test, so now you know what they are, right? And you know how to compute them. That shouldn't be a big issue now. So basically what we have done was that we were more or less finished with the OLS regression table. So you remember that we have the AIC, the BIC, those information were already computed. Today there was still some new items that I need to discuss, and let's say now is the time to. So basically, I would have sent this file and say, you guys do this computation at home and that computation at home yesterday. And then I said, I thought in the evening of Wednesday, I said, you guys work on the paper, because that is more important. You can develop some kind of feeling before we really move on, right? So today we do a little bit more of the of exploring the diagnostic tests in the regression model. So let's say the multicollinearity. So let's say the OLS model can only be estimated if the matrix of explanatory variable has full column rank. Again, don't think that I am insulting your intelligence. Because why are we talking about these basic things at this moment? Right now, we are talking about things that we already know, and we apply that into Python. That's the message, right? So in practice, a more common problem facing modelers is multicollinearity, not perfect collinearity. Yeah. So let's say you have variables that you want to measure different things, but they are so much correlated that they cause problems, right? For example, you want to measure two things. One is age, right? The age of the people influences their earnings. And then you want to measure, say, experience. Age and experience are two different things. But they can be very much correlated, right? But you don't want that. So one variable is so correlated with the other that if we all start schooling for the same finish education at the same time, then our age and our experience are more or less exactly the same. So that the two variables are different from each other by certain constant. That is when the problem of multipolarity arises. Okay, so the problem of multipolarity happens when one column of X can almost, but not perfectly, be a linear combination of other columns, right? Now I ask you again this question, and I want to make sure that you are all on the same page with me. Now, if I have a matrix X of x1, x2, and x2, xk, if I regress column x3 on the matrix X, what do I get? What is the what is the coefficient, the vector of coefficient? If I take one column of X and regress on the X, what do I get?
One column of X.
Let's think about it. I take a column of X and regress on the X, what do I get? Very simple one, right? No, I mean, what do I get here? I'm asking. That is the projection, right? What do I get? What do I get from if I regress x3 on the matrix of X that include x3 from x1 to xk? That
Itself.
includes x3. Yeah.
Itself.
Itself, right? So if I project X on the space expanded by the axis, I will get the X itself. I will get, so let's say, this is what I mean, right? So I do it once more and so you understand it and we can move on, right? So if I regress x1, x3 equal to, let's say, gamma 1 plus gamma 2, x2 plus gamma 3, x3 plus dot 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 plus gamma k, xk plus epsilon x3. Is that right? If I do this, I would get delta gamma 1, gamma 2, and gamma 3 in the normal regression sense. However, in this very special case, I would get gamma 3 equal to 1. Is that right? All of the other gammas equal to 0, right? And the error term
0.
So this is a perfect prediction because I predict something that I know. How much money do you have in your wallet? You know for sure because it is in the information, in your information matrix. How much money do I have in my wallet?
You know.
You have to predict, right? So then you have to use the variables to predict, right? So let's say in that case, your information, the amount of money that I have is not in your information matrix. And most of the time, your information matrix, part of the information matrix that you have is the explanatory variable. So if you want to use the explanatory variable to explain something that is not belong to the explanatory variable, you always make some error, right? But you try to reduce the error, right? In certain ways, right? Okay, good. Now, so let's say in order to express this problem in a systematic way, let's call the X is the matrix of explanatory variable in our regression model setting, right? X, k minus 1 explanatory variables. So when we say, and with a constant term, right? Xk is the k variable. And when I write xk like this one, I mean that the k variable is removed. Let me with me so we see the now, in order to understand, we need to agree on the notation. So we have matrix X with one constant and k minus 1 explanatory variable. Xk is the k variable and xk like this one is the whole matrix except the column k has been removed. Okay? Good. Now, so basically the messages in the x transpose x to the minus 1, okay, in x transpose x to the minus 1, that is that will have something to do with our variance covariance matrix. Is that right? Okay. So in the variance covariance matrix, the k diagonal element is the variance covariance. Is the variance of the coefficient of xk. Is that correct? Something, so in this case, what we want to emphasize here, and let's say I know that in your head you are having a question, but give me a moment. Right, so let's say basically the k elements. Diagonal element is the variance of okay? Okay, agree? Good? So it is the variance of beta. And the variance can be taken in this one. Right? And after some manipulation, we can express that the variance of the k element is defined as equal to 1 over 1 minus r squared of regressing xk on all other variables. Okay, so the r squared here is we regress xk on xk. Okay, so let's say in this case is the regression of xk on all other variables. By here I mean all other variables. Here I mean this one, all other variables. What do I mean? I mean it is x. Okay? Good? Now ladies and gentlemen, if xk is very much correlated with xk here, what happened? The r square will be high or low?
High.
High or low?
I swear high.
Very high.
Mm.
So if that is very high, 1 over 1 minus r square will be high or low?
Low.
Very low, right? And this one is very low. So 1 over something that is very low, it will be very
High.
large.
Mm.
So when it is very large, you construct the confidence interval of beta k. It will be large or small?
Large.
Very large. So it will be from minus infinity to infinity. So actually,
Mm.
is that right? You get me?
Mm.
Okay. Now remember when I am talking in this way, remember that how do we construct? I think. So let's say this is the variance of beta. Right? Variance of beta. If variance of beta hat k is very large, the standard error of beta hat k is also
Large.
very large. If that is the case, when you compute beta k, it will be larger than beta hat k minus, what is it? The standard error of, so it will be larger than beta hat k minus the standard error of beta hat k times the critical value. Remember that? Okay, and smaller than beta hat k plus the standard error of beta hat k times the critical value. So if this one is very large, you will have something that this one is smaller than 0, this one is larger than 0, right? So you have a confidence interval that includes 0, and you cannot make the conclusion whether the coefficient of xk is significant or not. Not because it is not significant, but because you have the problem of multicollinearity. What to do with it? You most of the time, if you have variables measure things that are highly correlated. There is a branch of research, they call it principal components analysis. They could group variables together into one. Otherwise, most of the time, we will drop one of the variables. In data, this is funny. But I think numerical analysis sometimes is very much problematic. So this is a funny thing that I was kind of startled when I was teaching the bachelor students. So when we include a variable that is perfectly collinear with the other variables in data, what does data do? In a regression, if you have one variable that is perfectly collinear with the other variables, what does data do? What does data do? You remember? You see that the variable will be dropped immediately. They don't talk about it, right? It is dropped, and the software keeps going. When you do that in Python, you get something that is highly significant. Because Python keeps estimating the maximum point, and because of the error term, it can still compute. It can still compute the variance. So you would expect this one to be 0. So when you deliberately create xk to be perfectly collinear with the xk here, with the xk here, right? You would expect this one to be 1, right? If this one is 1 minus 1 is 0, you would have infinity. The problem is this one is never 1. It would be 0.999999999. So then if you take that one, it's still not 0. So in Python, you have to be careful. You have to check another condition, that is the conditional number. Right? So if the conditional number is more than 10,000, you have to be very careful. What is the conditional number? I'll come to that later. But actually in the regression table, you see the conditional number. It is another very way of looking at this issue. But basically the idea is that it takes the largest eigenvalue value divided by the smallest eigenvalue, you get the conditional number. So the conditional number and the VIF, this quantity here, ladies and gentlemen, is called the VIF. And the VIF also indicates for you if there is a problem. So if the VIF is more than 20, you have to think of it. It depends, right? Sometimes 20 is okay. In other branch of research, 10 is already problematic. So it depends, but let's say the higher the number, the stronger the indication that variable xk is correlated with the other variables. And when it is more than 10, you start to raise your brows, right? Good. So are you with me? 100%? Not yet? No, okay. The why not I'm talking again because teaching also did a next step. Where is Nay? Which one do you want to talk again? Okay, then I'm doing once more, but I give you a secret, and then we will move on. Okay. Now, maybe one of you will ask me, why do I know that the k-diagonal element of this one can be written in this way? Right? That's it, right? So how can I write? I know that this one is the matrix inverse, right? But how can I know? This is expressed in this way, right? So let's say, basically, I think either in some years ago, I will go back to the book by William Green and show you the formula. Now I can do that with ChatGPT, right? So I will ask ChatGPT, how can I go from here to here? Okay. not started the class, I'm doing it again. But let's say before I do that, I'll give you some mathematical background. Okay? I will do this. I will copy this spot. I'm copying this spot. And I go to ChatGPT. This is where ChatGPT is useful. Let's say. So I have my project here. I paste it and I say, show me how I can get this result. But I said I will be, and because I know what I want, so I will say type the explanation using partition matrix inverse. Partition inverse. Okay. Haha. Okay. So let's say now ChatGPT knows me very well. I already talked to him quite a few days, and now I open this project. So he knows that whenever I open this project, he would recall that I am an econometrician and start talking in this way. Right? So all of the notations I have to tell him use the same notation that I want in the class. Yeah. So let's say basically the idea is this one. So you have I'm talking about math only. You have to be with me. I'm talking about math only. This is caring, not criticizing, right? So don't take it negative. Then, the first thing I want to do is, if I have a matrix like this one, I want to extract the diagonal element of it. How can I do it? Okay? If I have a special matrix of this form, I want to get the diagonal element of it, any of them, right? So what can I do? Basically, this is the goal is I want to get the KK diagonal element, and I want to show that it is equal to this one, right? This is equal to this one. So x here is equal to xk. That I take away the k element, and I add the k element here. So it is our x, okay? Get it? Xk is x when the k element is gone, is removed. Mk is the projection, the residual makeup. Fair enough? Good? With me? Good. Then that is orthogonal to the x. That is something we know, right? So we can partition the matrix X into this component. Fair enough? If we take X transpose X, we will get this one. Now we need to make the inverse of this one, right? Then I come to the secret here. The secret here is saying, if you have a matrix of this very special form, okay, then the inverse of the k element, let's say the inverse, the C, now, ladies and gentlemen, forget about the left hand side, look at the right hand side. If you have a matrix of this special form, mathematically you can prove that the inverse, the C, if you take the inverse of this one, okay, the element in the position of C can be proved to be equal to this one. Okay? Now, forget about, let's say, I will do a magic here. How can I do that? Do something. So let's say basically, I want to hide away something. I know it's difficult to hide away, but I do this, right? Do this. So I try to move away this way. Right? So you see only the left hand side and the right hand side. Okay? If you have a special matrix like that one, like the one here, if you have a special matrix like this one, right? Okay? Like this one. And if you want to inverse it, and you want to compute the element of the inverse here, that element can be expressed in this way. This is a branch of linear algebra. This is proved in the book by William Green, Econometric Analysis. Okay, good. Now, so now I apply the right part to the left. Okay, so now I forget about the right. I assume that you all know the right. Now we focus only on the left, right? How is the X transpose X expressed? It is expressed here. Okay? So I would define A equal to this one, B equal to this one, and C equal to this one. Then I apply the formula on the right, I would get it equal to this one. And if I apply this formula here, I will get it equal to this one. Okay? This is what I have in my screen, right? On my slide. Right? And then after some time you see this one. So this is what I have here. So going from here to here, it is a math issue. Okay, good. And do it again, all over again. So you know the math, okay? Now, dear Mr. Chi Chung and dear Mr. Thanh Vi, I start this morning by talking about the problem of multicollinearity. Right? So what do I mean by multicollinearity? I mean this one. So basically, when we have a matrix X, we would expect the independent variables to be correlated because this is social, it is life. You will hardly get any two columns, any two variables that are completely unrelated. Most of the time, if you compute the covariance, the variance, or the correlation coefficient, there somehow exists something, right? So, for example, if you, if you take the correlation between the amount of rain and the amount of days that you feel bored, somehow it is also correlated. Right? So that's something. Even though maybe it has nothing to do with it, with that, but it's still correlated. Now, so in economic research, we want the so what happens when a variable is highly correlated with the others? What is the economic meaning? The economic meaning is that variable doesn't bring any new information. You get it? It doesn't bring any new information. So all of the information that it brings into the matrix could be explained by the other variables already, right? Mathematically, that means it will, if it is perfect, you will not be able to compute the inverse. So that you need to compute the estimated coefficient. So let's say it is like a mathematical gift to warn us that you have included variables that are not wrong, right? Okay, good. Now, so let's say for that reason, sometimes you may run a regression model on a variable that you are focused on. You want to explain it, right? But when you run the regression, the coefficient of that variable is not significant. May not be because that it is not significant by itself, but because it is highly correlated with the other variables, and it gives you the wrong answer. Okay, so how can we say that that is the case? We start with by defining X is the whole explanatory variable matrix. Okay, K is any column in X. Okay, and Xk is the matrix X that we remove the K variable. That's it. So that this is the, let's say we come to the center. Good. So the purpose of this slide is to show us the consequence of highly or of multicollinearity. So let's say if we want to inverse this matrix, then the kth element of this matrix times sigma square is the variance of the coefficient of the xk variable. Fair enough? So we know that so the k element of this one can be rewritten in this form. How? We already showed it mathematically before, right? And it could be rewritten in this one, and after some manipulation, you can be rewritten in this way. So this new term, this new calculation is defined as equal 1 over 1 minus the r square of regressing xk on all other variables. Okay? Now, so if xk is highly correlated with other variables, you would expect this one equal to 1. Right? Is that correct?
Yep.
Correct? If 1 minus 1 is something very small, the variance of beta k will be beta hk will be very large. Right? If it is very large, when you construct the confidence interval of beta k, it will be equal to beta hk minus something that is very large. It is likely to be negative. And it is when beta hk plus something that is very large, it is likely to be positive. So the confidence interval will go from minus infinity to infinity. You have no conclusion. Not because xk is not relevant, but because it is correlated with the others. Get it? Okay. So this one is known as, the name of this one is known as the VIF. Okay. This one is a VIF. Let's put the VIF. Is equal to 1 over 1 minus r squared k dot. That's it. Nothing more. The VIF is that one. Okay? So if the VIF is larger than 10 or larger than 20, it indicates that variable k is highly correlated with the other. Sometimes you have the VIF that is equal to 4,000. That's quite problematic, right? Good? Get it? Now, so now if I ask you to compute the VIF in Python, can you do that? Yes or no? Yes, right? That's how you know to program. That's the idea of programming, nothing more, right? We are going to go into more technical things today, but that's the idea what we mean by programming. Programming is rewrite what we know, the algorithm that we have spent our wisdom on deriving it, right? And then just apply it. So Python is nothing more like a slave that he will excel at number crunching, but he doesn't know how to derive. You have to do the derivation. Get it? Now, so this is something I need you to remember. So this is something, now you read it at home, but basically the message that I send you is this definition. Good. So let's say if now we go back to the regression analysis that we did before, right? Let's open the file day2. Even though it's named day 2, it is a continuous of a lot of days. So I would put day 2 part 2. Where is it? Day 2 part 2. So last time, where were we? Miss Laming, you are with us? We were talking about the LR and the LM here, right? So let's say now let's add a little bit and talk about the VIF. Now, I would ask you guys to program the VIF on your own. This is your opportunity to do the VIF on your own. With this update, what do I mean? I am not showing you guys the code, right? So last time we were here, right? Last time we were working on this database, data set. We already computed up to the Lagrangian multiplier test. Now let's say we define everything the same. Right? We run it. We load the data into the memory. This is what we get. We run this bot. Okay. Now, your job is to do the VIF. I think we can start from here, and let's say I will copy it down to the bottom later for the sake of having a consistent organization of the information following the order that we did in the class. But let's say now you have this one, and you focus on Act 2, and your job is to check if the log of total income is highly correlated with other variables. Okay? So let's say the job I want you to do is now, let's say, now, check if log total income is highly correlated with other variables. Doable, right? In the examination, if you have this one, it's totally doable. Is that right? Now, so I would need you in this case, because we are learning programming. If you do model.ivf, you get it immediately. I don't want that. Okay? Is that correct? Now, if you do print model.vif, you get it in no time. Is that right? But let's say that is not what we want for, right? Of course, after doing this, we will be very much confident about our skills, but let's say we need to do it manually, right? So let's say if you run this model, right? If you run this model, and you put in the cell console, you put print model.vif. It's next no attribute to VIF. So it doesn't remember VIF, but that's fine. It's data you have. So in Python is created by his friends, the computer guys. So sometimes they don't share the. I mean, me now is an economist, but let's say the computer scientists sometimes do not share the same concern with the social scientists. So sometimes they would say compute the statistics that economists may not care that much, even though in their research it is more relevant. So let's say I'm going to demonstrate something that you know very well, right? So let's say this is what we have for the I'm going to open this one, and if I run any regression, let's say if I run this regression, right? If I run this regression now, if I run I'm just demonstrating the useful of. So let's say if I run this one and I type, if I run any regression and I type stat VIF, I would immediately get the VIF for all variables. You see? So in Stata, the VIF is stored in the memory. So if you type stat estimation statistics VIF, you get the VIF for all variables. So there is something warning here that the coefficient of the H categories are equal. So most of the time if you do modeling, you would be do the eyeballing.
So it is just it will require that specific variable on other exponential variables, right?
Yeah, it does.
Okay.
You understand the logic, right?
Yeah, so that's I think like in Python we don't need to run the model first, but we need to know the code because the code will do the question without doing the full question of y on or
No,
x.
it would not. So that's why now I need you to implement this into. You implement this one, right? You don't do the. You don't call the result. Initially I try to show you that we can call the saved result in Python. Actually, Python, the library, OLS library in the stats models does not compute this one, but it computes something else. What does it compute? Now, what does it compute? Print model summary. What does it compute? In Python, it does not compute the VIF, it computes this one.
condition
Yeah? The
conditional number.
So what is the conditional number? The conditional number is you take the largest eigenvalues of X transpose X divided by the smallest eigenvalues. Okay, remember that we divide lambda max divided by min. This is the conditional number. Can you compute that? Yes, let's do it, both of them. Okay, so what is the indication here? If the conditional number is very large, it also indicates that at least one of your columns are
Correlated.
highly correlated
Highly.
with the other. Get it? Okay, so this is the meaning. You have to get it? So you have 4 minutes to do the calculation. Now, bây giờ thầy nhờ cả lớp một việc. Thầy nhờ cả lớp một việc. Là các em ngồi, bây giờ các em đi từ trên này đến này. Bữa nay một lần này, lần cuối thật thầy sẽ đi rất nhanh, cái phần còn lại thầy không đi chậm nữa đâu. Nào. Bây giờ thầy yêu cầu cả lớp giúp thầy một việc. Là hãy bắt đầu ở mô hình này. Được chưa? Và compute cái VIF này manually. Được chưa nhỉ? Không được dùng nó không được dùng cái big library. Các em tự compute X transpose X to the minus 1 times X transpose Y, you get what? Okay? Và các em chỉ cần compute cho thầy mình cái này không? Mình cái học này không? Được không? Làm được không? Nhanh mà đúng không? Nhưng mà việc các em phải làm bây giờ là các em phải define rất nhiều thứ nào. Bây giờ thầy muốn các em làm manually, làm được không nhỉ? Rồi thầy đã gửi cái slide này rồi các em xem đi. Với thầy chiếu cái này để các em nhớ nhá. Chiếu cái này để các em nhớ. Chỉ làm cho thầy cái chỗ này không? Thử đi nào, tất cả các bạn cùng code nào. Các bạn code như vậy là rất nhiều thứ, các bạn code tất cả những thứ học từ bữa đến giờ đấy. Nào là bạn phải lấy ra thế nào là X matrix. Bây giờ trong trường hợp này, bạn đang định regress cái thằng này này lên những miếng còn lại đúng không? Vậy bạn định nghĩa cái miếng còn lại là gì, bạn phải định nghĩa. Nào, cùng làm cho thầy. Cùng làm cho thầy. Cùng làm cho thầy xong mình làm lên có lẽ đây là lần cuối cùng. Mình bắt đầu tự code nha, bởi vì là thời gian mà nó mà gọi là dạy để code thì nó sẽ rất là tối và nhiều khi chúng ta không đủ lên đây. Em làm lót tô rồi cam thì em làm được cho mình. Thằng nào cũng làm đúng thế đúng không? Như vậy cái lót tô income chỉ cho biết một câu là lót tô income nó có hai đi qua rồi biết còn lại không? Lên những thằng nào rồi mình cũng không được lấy cái OLS dot R square ra. Em làm bằng manual thì hết trơn. Bây giờ như vậy là các em sẽ phải quay lại các em tìm Trong library của em đã làm gì từ bây giờ đúng không? Vậy đi thi nó vậy đó. Với đi thi khó mà thoát những câu kiểu như thế này. Tức là những câu làm trên lớp rồi. Thì bây giờ mình sẽ define nó lại là những cái câu làm sao? Tương đối là tương tự nhưng mà với cho một variable khác hoặc là cho một con này. Một công việc của thầy thường dạy với các bạn trên lớp là thầy đang dạy những thầy shift sang tiếng Việt là hoặc rất giận dữ hoặc là rất muốn truyền một thông tin mà cần phải làm bằng được.
Có income total and in your
Sao em?
cái biến nó tên là log income total. Thì em kiếm thử có tên của cái biến lấy lên cái dữ liệu lớn nhất luôn đúng không thầy? Cái dữ liệu nó có nhiều cột nó có thể
Đâu, nhìn này, nhìn cái cốt từ trên này xuống đây, đây là cái cốt từ ngày 2 ấy.
là thầy lấy data 2 phải không?
Ừ, đó là 2.
Nhưng mà là log income total. Cái tên nó khi nhìn lên bảng lấy chứ không có ra, nó không chạy luôn thầy. Cái này đặt tên là log income total, trên bảng thì ghi log total income.
Ồ thế à? Thầy xin lỗi.
Đem giọng ra, cái biệt này ra.
Ví dụ như bây giờ mà cho anh 100 câu hỏi program từ giờ đến hôm thi là sẽ thành chuyên gia trong programming đúng không? Bây giờ biết programming là gì rồi đúng không? Yes, everything from step 1 till the end. Everything must be done with your own calculation.
Okay.
You cannot use any written command. Okay. And this is what you will have in the examination. But I will reserve something in my hand already, right, over the last few days, what I want to ask in the examination. It will be similar but different from what we are doing. Không cần có bộ
Yeah.
Hết chưa? Các bạn cầm kêu hết chưa?真rồi hả? Tuyệt vời.
Siri.
xong rồi chia chung hoàn thành bước 1. Nào, print mở ngoặc trong này là gì? The variance inflation factor of the log of variable log total income is Do you have this number? No? So I did something wrong. What is your number? Pardon? 1 point? 1.2, right? Everyone get the answer?
My X capital have more valuable than you.
My X, your X capital.
Yeah, I also do.
You have
Yeah,
more
yeah,
variable
yeah.
than I do.
Yeah, yeah, but I will edit it.
Okay, so let's together go step by step and see where I did wrong. Okay. When you are on the same page, you are already ready or not yet? If not yet, I give more time. Okay, so I will give you more time. Kiết Anh. Đấy. Ngọc Anh. Okay, done. Done or not yet? Okay.
Done.
Okay. So what is the route that you have taken?
1.2, 1.5.
I think I made some mistakes sometimes. Okay. I forgot the inverse. This one, right? So it must be NP dot linear. So let's see if we are on the same page. So I have a very large number. So this is xk transpose xk to the minus 1 xk transpose.
You haven't swear some
Swear.
Okay. So it must be it must be it's Is that correct?
Yeah.
Okay. Let's see what I.
And you have the VIF formula also have xk
Oh,
equals
yeah, that is same.
xk, you just write the minus r square only.
Oh, this is the definition of the VIF.
Ah.
That time xk is the whole variance of the variable. So we are on the same page?
Yes.
Doing the same thing, right? Would you, did you get the same number? Okay. Why same number then? Đăng Thư, Minh Quân, yes. Nguyên, no, because you know something you want to
I got it now because I calculated the wrong thing.
Right. So let's say this is, so I took this route. There will be many other ways of doing, right? So I can also take the covariance. So can anyone, let's just for the sake of practicing, can you compute manually the correlation coefficient between this variable and this variable? Can we do that? What is the correlation coefficient and the correlation, the covariance between them, and the correlation coefficient between them? That's it, like the square root of the variance. Yeah, so let's say I give you a general number and you can do it quickly. So if you have correlation between x and y, right? It will be equal to the summation of what? X minus x bar times y minus
y bar.
y bar. Over here you have the square root of
X
summation of x minus x bar
square.
square summation of x y minus y bar
Square.
square, right? Program it. Now you know what we mean by program, right? Do it. So let's say quickly, and you can also compute the r square in the other way. Is that correct?
3 ways.
3 ways, but let's say this is another. So in the end, if you know the math, if you truly understand the model, this one is just a piece of cake. That's very easy. Yeah. That's the message that I always want you to take away. So in the examination, if I give you this one, you won't be able to compute, right? That's one question. 9 minutes. 9 minutes. không? Cái này thì không rõ. Chỗ này Henry, chỗ này mà đem mà enter nó thì nó có chịu không?
Nghe thử này.
Người ta nó có search ra cái đó không, nó sẽ báo lỗi. Nó vẫn chạy mà. Vậy thì thầy sẽ làm điều, thì làm như này cho nó dễ thấy đúng không?
Thường mình nên đặt tên đến mới để tính cái cục đó. Chưa biết code dạy cái người đọc code mình chịu không nổi.
Nhớ là sao?
Đấy
Em
là
đặt.
mấy cái bước trung gian người ta đặt cái tên mới chứ không để vậy. Cái người đọc code người ta hơi căng thẳng.
Rồi. Cái này mà muốn có đấy thì làm sao?
Tìm cái đặt covariant đi variant hoặc variant.
Ok, tôi hiểu. Chỗ này mà thầy muốn xuống dòng thì làm sao? Mấy món này bên các bạn cầm. Thực ra thì không ấy thì mình sẽ type vào các GPT đúng không? Ok này em thử.
Xuống dòng thì có quyền không có lỗi.
Mình thì có lỗi mình phải nó phải đòi xuống dòng là phải có chữ N mà.
Dạ, nó phải
Đó. Nếu mà muốn xuống dòng thì phải print lại. Được không anh? Anh làm chưa? Ok, ra có dấu dốc theo. Sau ra số của thầy lại nhỏ hơn của các em rồi.
cái số gì? Cái RK square hay là cái RK square
Thầy đã print cái này.
0.17
Cái 17 à?
0.1769.
Cả hai cách của thầy đều dùng một số luôn đó thầy.
Nó phải là trong một số.
R square của các em. À, thầy là R square, các em là correlation coefficient.
Không, correlation tới 0.4.
Gì đúng rồi, bình
Hai.
em bình lên rồi thầy.
Em nhìn lên được không?
Dạ,
Ở 0.17.
correlation với
0.17 đúng không? Thầy 0.17 em mình lên thầy đoán ra con số.
0.42 cái correlation là 0.42 thầy. Cho nên mình lên là 0.17.
Tiếp theo.
Dạ.
Vậy thì nhầm ở đâu? Là một cái message mình sẽ thấy là làm nó sẽ nhầm liên tục.
Ở trên này không có được square root nó thì square root hay square root cái tử luôn. Cái correlation, cái covariant nào thầy cho nó vô cái square root luôn này.
Tất cả là square root chứ. Square root trên là square root ở dưới. Bởi vì là R square nó bằng gì? R square nó bằng gì?
À không, nó không thích correlation nữa này.
Correlation đúng không?
Correlation đâu có căn với trên được.
À đúng rồi, thì
Sum.
Ở trên bình thường.
Sum á này, nó numpy sum.
Chỗ đó không cần sum. Nó nhân
ok.
còn giờ thầy cẩn thận đúng không? Có dừng lỗi cái ngoặc tròn cuối cùng nó xuất hiện gì? Thầy copy cái đó vào chắc được.
Rồi.
Thầy bên cái call của thầy và cái correlation của thầy. Hỏi chỉ print cũng được rồi, ghi tên ghi nó cũng nhẹ.
Đúng rồi.
Dạ đúng rồi.
Rồi. Thế Thế thì cái R square này nó sai ở chỗ nào? À không, vì
Không.
phần trên này
Thầy
nó
rên
sai.
lại một lần nữa. Thầy rên lại lần nữa.
Thầy chỉ cần mấy cái cô đó bình phương lên là
Okay, so we are on the same page, right? So now I'm going to do this, and then
Đúng rồi, đúng rồi.
no, in this case I don't need the
gì
I don't need the okay, right? Get it?
anh gọi cho cái bình phương lên, cái tận phải bình phương lên, cái mẫu không còn căng như cái tận phải bình phương lên.
Let's say
Giống mặt xong rồi lại sao sao.
Power 2.
can I do this? No, it will not work, right? It will misunderstand. That's the last
Thế
one.
là thầy phải để cái nhân hai bên ngoài, tại không nó sẽ nhảy. Em không biết là nó có là nó nhảy vô cái scan trước đó thầy.
I think so. Yeah. So let's say at least I have to do
Vậy
this.
đó là cái nhân sau như vậy. Dạ.
You complaining?
Bên lúc.
So say if I don't do that, keep moving.
Ủa?
Let's ask ChatGPT what is wrong here. So let's say some years ago, without ChatGPT, if there is a mistake, it could take hours to fix it. Right? So what is that? It must be in one single line. If you want multiple line, you have to put it. So what's that? Option 1 in a single line. Option 2, if I want this option, what should I do? Let's see. Oh, so what is the difference? I need to put them all in one parenthesis. Is that right? Or what?
Ờ, bị thiếu dấu ngoặc.
If we want to enter in a one computation, the long line of computation, we need to put it into the parentheses, right? Okay. Good. Everyone is on the same page. So now, if I give you the map, you know how to do it. That's what I mean by programming. Okay. So that's the course is more or less done here in terms of computation. Now I'm going to move on with normality. Now I'm not going to do this, okay? So this will be, if I don't do it in the class, you will do it in the exam. That's normally the message that I will give the student all the time. So this is the test where so let's say we need to, the idea is that we are going through all the assumptions of the linear model, right? So we started with the linear assumption, and then we did with, what's that, multicollinearity, right? And then we did with heterodidacticity. No, not yet, not yet. So now we're doing it. Yeah. But let's say, now we are talking about the normality assumption. Okay,
In 10 minutes is enough.
Okay, 10 minutes. 5 minutes, okay? Okay, let's do a 10 minutes.